Hello, everyone. Yeah, another MetaMates here. I'm excited again to speak about Lineage Quality Measurement Framework today. My name is JiSu, and I'm a privacy engineer at Meta. But this presentation, I'm going to be having the honor to speak, but it was a group effort, and it was put together by this group as Francesco and Alex slyly moved across the stage. We are a group of software engineers and a privacy engineer who work closely together in solving some wide variety of interesting privacy-related work at Meta. And it was one of our endeavors together, alongside our other wonderful coworkers, that we started building the Measurement Quality Measurement Framework. Did I say that right? Yes. It's a guiding set of principles on how we will measure and assess the quality of our Lineage tools. But before we dive further into the framework itself, we first wanted to talk about what Lineage is, and then discuss some of the problems we saw in the development and usage of Lineage tools. And then we can finally circle back around and talk about one of the solutions we have implemented to mitigate for those problems, which is the Lineage Quality Measurement Framework. So without further ado, let's dive in. So what is Lineage? Lineage is a mechanism that allows us to understand our data flows in our system. And this is really important for privacy because we need to understand where our data goes in order to protect them. And quick disclaimer here, Lineage is of course not the only tool used for understanding data flows, but it is one of the more frequently used tools that we want to dive deeper into. So anyways, Lineage, beautiful concept. It's hard to implement. There's going to be many variety of ways an engineer would develop a Lineage tool, and that's because there's different types of data, different types of tech stacks, requirements, methods, etc. But instead of me just listing on and on about all the reasons the tools can differ from one another, let's just walk through a simple example to help conceptualize this. Here is a function that processes driver's license image. In line 1, we get the image from our user. And in line 2, we store the exact copy of that image. In line 3, we extract some information out of that image, specifically the birthday. And in line 4, we store that derived birthday data. In line 5, we calculate how long the function took to run, and in line 6, we log that calculated time elapsed. We can pretty easily see here that the privacy-sensitive data source is the driver's license image. And the downstream data flow we will want our Lineage tool to find is the storing of the image itself and the storing of the derived birthday data. So how do we implement a tool that will capture this information for us? Again, and there's going to be many variety of ways, but they're all essentially going to be some approximation of finding where that data source has gone. Let's implement some hypothetical Lineage tools together to showcase this. Implement. Well, here's my Lineage tool number 1. And let's say using static analysis, it identifies all the write calls it has made after collecting the image. It can tell us with pretty high confidence on all the potential locations our image might be stored in. However, it also means we could be flooded with false positives in certain use cases because it's reporting back way too many paths that don't actually contain the privacy-sensitive data that we care about. In this example, the logging of the time elapsed. So I go ahead and implement my second Lineage tool here, and it can successfully tell us where it stored the exact copy of the image. Maybe the tool did this by analyzing some additional request logs and filtering out some variables that don't hold the image. But this tool can only give us one of the 2 privacy-sensitive data flows that we needed to catch. So I implement my third tool here, which finally does find that derived birthday data. But in order for Lineage tools like these to function really well, it needs to have a deep understanding of the code base because it needs to understand the data transformations. And that can be challenging and complex. So depending on the implementation, we might be circling back to the problem our first tool had, where it's collecting too many flows, or the challenge our second tool had, where it's potentially missing some flows. So hopefully this was successful in communicating why there are many varieties of Lineage tools, and that there are distinct challenges and advantages to each Lineage tools. this is the best part. I like to say they are like fruits, or at least a kindergarten concept of fruits where each fruit has a unique vitamin property. And there are advantages and the need to consume all these different types of vitamins. And though we can't grow a super perfect single fruit that negates our need to ever consume any other fruits, we can aim to make the perfect fruit salad for each customers. And that's the goal with our Lineage tools. But now the challenge is we have many varieties of Lineage tools being developed and being merged in order to complement for one another. And this introduces the inherent problem we get in using multiple tools. One problem can be the inconsistencies between the tools, like their techniques to measure its quality. And that makes it difficult for us to understand which tools we can use together and whether the combined efforts was actually successful. We essentially get the problem of trying to compare apples to oranges here. So to resolve for this issue, we needed a centralized mechanism, or a common language, if you will, that will surface what we have, where to improve, and how to optimally use our resources. This helps us to have that deconflicted, unified view of our Lineage tools that we can trust. Okay, now we can circle back and reintroduce you to Lineage Quality Measurement Framework. As mentioned in the beginning, it's an overarching guiding set of principles on how we will measure and assess the quality of all our Lineage tools. This aims to be that common language that we just discussed we needed. So there are two main components to the framework. First, we need to all align on what type of metrics we will catch to reflect the quality of our tools. And then we can use those metrics to create analysis and guidances, etc. We'll be mainly focusing on the measurement component today. So in order to define how the quality will be measured for a given Lineage tool, we essentially wanted to answer two questions. First, how many of the expected flows did the tool find? To answer this question, we needed a set of privacy-sensitive data flows that exists in production that we know the tools should find. This was our ground truth. Let's say we have a system that simply implements that example function we talked about earlier. Here, the ground truth flows will be the flow from the image to storing the exact copy of the image, and the flow from the image to deriving the birthday and storing that derived birthday data. Once we have our ground truth, then we can calculate how well the tools did in finding them. This was our recall. So bringing back our two hypothetical tools from earlier, we can calculate that our first tool has 100% recall because it found all the ground truth flows. And our second tool has 50% recall because it only found one of the two ground truth flows. And that was easy, but unfortunately, in the real world, we cannot calculate the true absolute recall like we just did, because that will require us to know all the relevant data flows ahead of time to curate our ground truth. And at that point, we don't need Lineage tools because we know all the relevant data flows already. So instead, we calculate our recall as an estimate using some sample of ground truth. We say sample, but we can calculate how much sampling we have to do to gain sufficient amount of confidence. So the challenge mainly lies in gathering these high-quality, unbiased, representative set of ground truth. Thankfully at Meta, we have a cross-functional process, and products that use user data goes through a privacy review assessment. This is a prereq for launch, so it's an ideal place to have our experts all chip in providing some expected data flows. Over time, this pile will grow into a sampled representation of our ecosystem. This means our confidence will continue to rise as we keep collecting ground truth. Awesome, so we have one aspect of our quality now measured. The follow-up question we then had was, of all the flows the tool found, how many were actually expected? To answer this question, we needed to retroactively check all the flows the Lineage tools have found, and then identify how many of them are indeed downstreams of a privacy-sensitive data source. Once we are able to label our flows with this information, then we can calculate how well the tools did in finding just our real flows. This was our precision. So once again, bringing back our two hypothetical tools here, we can go ahead and mark all the data flows as expected, except for the logging of the time elapsed in our first tool, because that is not a real downstream lineage of our driver's license image. Once we label those flows with this information, we can calculate that our first tool has 67% precision and our second tool 100% precision. But now we have that question again of, okay, well, how do we get the information of the flows being real or not in a larger system? And unlike ground truth, the data required to measure our precision is dependent on the lineage output. So we can't collect it prior to running the tool. So we have a process in place that randomly samples our lineage tool outputs, and we have a group of experts vet for the flows being relevant or not. And that's it. That's how we aligned at a high level in capturing recall and precision to reflect the quality of all our lineage tools. Now, once we are able to have all our tools use these common metrics and the common method to reflect these metrics, we can almost like catalog our tools using recall and precision and make assessments like what tools might do potentially better with another tool. For example, we saw that our tool number 1 had high recall but a lower precision. It may indicate that it might do better with some corroboration with our tool number 2, which had that higher precision but with a lower recall. These type of analysis will be a continuous journey as we aim to make that perfect fruit salad for our customers. And so to wrap up our presentation, I put together some lessons learned. And the lessons I've learned during this process is with wide variety of use cases that uses data flows, naturally comes a wide variety of lineage tools. And as much as building these tools are important, building an unbiased, common quality measurement framework that gives all our tools a proper reality check helps us to improve our tools in a more meaningful and resourceful way. So though we focused on lineage tools and lineage quality measurement framework today, our hope is that our working model here can be expanded to other use cases and other tools in the future. And that concludes our presentation. Thank you, and we'll take questions.